Hey there, back again. We've had some time to talk about square roots and cube roots and radicals in general. Uh, there are actually more things that apply with radicals than just that. So here we start to take a look at section 5-6, radical expressions. We're going to break this into two parts. So this first part is going to focus mostly on multiplication and division, and then we'll pick up with addition and subtraction in the next segment. So properties of radicals, multiplication, basically what we're saying is this. If I have two radicals at the very least, maybe more, and they have the same index, we'll call it n. So we're looking at the nth root of a times the nth root of b. Again, it could be two square roots, could be two cube roots, could be a fifth root of something times a fifth root of something else. Because they have the same index, okay, again, the index is that little number right there, I can go ahead and actually multiply the two values together and say it's the nth root of a times b. So, for example, if I had, oh, I don't know if you heard that, but the bell rings, so class must be over. If I had the cube root of 5, and I wanted to multiply that by the cube root of 10, because they're both the cube root, I can actually call that the cube root of 50. Okay, if I had the square root of 2 times the square root of 600, I could call that the square root of 1200. And so that's what the multiplication property of radicals allows you to do. The division property of radicals, and it works backwards as well. So if I know that I've got the cube root of 50, I can work that back into the cube root of 10 and the cube root of 5. And if I've got the square root of 1200, I could call that the square root of 600 times the square root of 2. So it'll work both ways. Okay, you can multiply stuff together, you can break stuff apart into an actual multiplication problem. Division is very similar. So with division, if I have the nth root of a number divided by another number, that's the exact same thing as saying that's the nth root of a divided by the nth root of b. So let's say I've got the square root of 10 over 6. That would be the same thing as saying that's the square root of 10 divided by the square root of 6. Okay, and again, I can go back in the opposite direction. If I've got the square root of 27 and I want to divide that by the square root of 9, I can say that that's the square root of 27 over 9, which then I could eventually just call that the square root of 3, because I can take 27 and divide it by 9. So it will work in both directions. And it doesn't work with just square roots. It's any type of root. It's just that the index have to be the same. Okay, so a couple little rules here for you in terms of simplifying. So if I want to simplify a radical, which means if I want to try to put it in its lowest form, kind of like when you simplify a fraction, 5/10 is 1/2. We can simplify radicals. We can try to make them in lowest terms, if you will. The one thing I have to make sure is that I don't have any fractions underneath the radical. I know fractions are your friends, but here apparently fractions and radicals are not so friendly, and so we've got to make sure that there are no fractions underneath our radical symbol. 2, because of that hostility between radicals and fractions, fractions like, well, hey, Mr. Radical, you cannot be in my denominator. So no radicals in the denominator of a fraction. 3, our index must be as small as possible. So if I'm taking like the square root of a square root of a square root, I'm going to work to try to make sure that that index is as small as possible. If I'm taking the 4th root of a 10th root, I'm going to try to work to make sure that index is as small as possible. We may deal with that a little bit, but maybe not a whole lot. No other factors can be nth rooted. So if I start to simplify a radical, but then I notice that I can continue to simplify it because I didn't go far enough the first time, then I'm going to keep going. It's like if I said, if I had like 10 over 20, if I had the fraction 10 over 20 and called that 5 over 10. Well, I reduced it, but I didn't reduce it far enough to call it 1/2. So that's what we were talking about with this last point right here. If I can keep simplifying it, I'm going to try to do that. So that's where we're at this point. Any questions? John? Jim? No? All right, well, let's keep moving on then. Excuse me. So we have a process called rationalizing the denominator. And rationalizing the denominator comes into play when we have a problem with that second bullet point, that we've got a radical in the denominator of a fraction. And it's something that we can kind of fix with not, hopefully, too much difficulty here. So let's say we've got an example here. Let's say we've got 2 divided by the square root of 5. So obviously the square root of 5 is a radical, and we don't want radicals in our denominator. So what I'm going to do is I'm actually going to multiply my first fraction by a second fraction. That fraction will be determined by whatever I have in my denominator. I have square root of 5 in my denominator, so I'm going to actually multiply by the square root of 5 over the square root of 5. And this is why. When you multiply fractions, you multiply straight across. So I take 2 times the square root of 5, and I just write it exactly like that. Leave the 2 on the outside, the square root of 5 stays the same. In my denominator, because I have square root and square root, I can multiply those numbers together. And so I get the square root of 25. The nice thing is this. I know what the square root of 25 is. So in my numerator, everything is staying the same. Okay, 2 times the square root of 5. In my denominator, the square root of 25, I know what that is. I can figure that out. That just equals 5. And so this becomes my answer. 2 times the square root of 5 over 5. And that's what we call rationalizing the denominator. So let's look at another one real quick here. We've got 4 divided by the square root of, we'll say 2. So again, square root in my denominator, I don't like that. So I'm going to multiply by whatever's in that denominator. So that means I'm going to multiply by the square root of 2 over the square root of 2. Again, we multiply fractions straight across. So I've got 4 times the square root of 2. Because I have the exact same type of index here, square roots, I can multiply those together. And so I get the square root of 4. But luckily for me, and for you, you know the square root of 4 is 2. Now the nice thing here is this. This is a special problem, because if you look right here, you've got a 4 on the outside, you've got a 2 in your denominator. We can take 4 and we can divide it by 2, and we can find out that 4 divided by 2 is just 2. I haven't done anything with my square root of 2, so that in fact is my answer. All right. So that's where we're at in terms of rationalizing denominator. We're about 9 minutes here. Let's get a couple quick problems in. So you see I've got a whole list of them here. We won't do every one right now because we'll do some in class. Right here, let's focus on number 3. The square root of 3/4. I'm not allowed to have a fraction underneath a radical, so I'm actually going to split this up into the square root of 3 over the square root of 4. I cannot take the square root of 3 evenly. I leave that alone. I can take the square root of 4, which is 2, and so I do that, and that's my answer. Let's check out something like number 5, because I've got a radical in my denominator. So I need to multiply by a fraction. Square root of 2 is in my denominator. That's what I multiply on top. That's what I multiply on the bottom. We'll probably talk more about that in class as well. So I've got 6 times the square root of 2 divided by square root of 2 times the square root of 2. That's the square root of 4. I know that the square root of 4 is 2. Again, extra fun for you and for me. 6 on top, 2 in my denominator. I know that I can divide that out and get 3. My square root of 2 has not changed. And so I've got that answer. You can try number 6 on your own here real quick. Go for it. Pause. Unpause. Here we go. So multiplying by the square root of 7 over the square root of 7, which gives me 14 radical 7 over the square root of 49. I know that that's 14 square root of 7 over 7. But again, I can reduce. I can reduce that. And so my new answer, we'll go with red. 14 by 7 is 2. Got my square root of 7. Got it. We'll talk more about these in class, especially problems like numbers 1 and 2. Show you how to simplify this stuff out. So have a great day. We'll see you then. Peace.